Okay, welcome to Prac 4's Memo. So let's dig right into it. So the purpose of this practical is for you to become familiar with the basics of inheritance and polymorphism. So inheritance, basically, when you see that classes more than one class, right, has common attributes or um, common data and functionalities. So, for example, let's say I have, um, let me see. So let's say I have fruit. So let's say I have fruits, right? So let's say I'm going to have a banana first, and then this banana is going to have, okay, let me just make it private for now. This banana is going to have a color, and this banana is going to have some shape, right? Let's say we have the shape class. So it's going to have some shape. And then this banana is going to have some price and things like that, right? So I redefine the same class, and then I have another class. Let's say we call this um guava, right? So I'm going to have that, and there's the same properties. There's the exact same things. So since it has common features, right? That's the way I introduce inheritance. And then basically inheritance is like you having a parent from which you inherit your specific attributes. So I'm going to create a base class. The parent is called a base class. So what is this parent? What are you going to call the parent? So what are these two things? What are they called? These are fruits. So I'm going to create a fruit base class. Then anything that I'm supposed to make private, I'll make it protected. So protected in the sense that it's public to anyone who's a member of the member of who's a family member, or anyone who's a child of this class or a child of mine is going to have this public. It's going to be free for them, public to them. But then anyone who's not part of the family is going to be private to them. So it is still safe. It's a safe um, member. It's a safe access modifier. So now instead of me having to redefine this over and over, I don't have to do that anymore because now I have a base class where I put the common attributes or the common properties and functionalities. So since I have a class that contains these two things, what's the whole point of inheritance? It's called inheritance because now I can just inherit from my fruit class. So I'm saying public because I'm inheriting the public properties. Remember what he said, protected, it means public to the child classes. So that means they still do have this access. There's access to those variables, those member variables. And then this one is going to inherit from the same parent because these are both children of this fruit class. Why am I saying so? Because banana is a fruit. Guava is a fruit. So I'm using is a because it's normally called an is a relationship. So before you can create this base class, you need to check if there is an is a relationship. So there is here because banana is a fruit and guava is a fruit. So both are fruits. So that means they both have a parent. They both have a base class. So that's what you're going to implement here. So we're going to use inheritance. So we're just going to add on to what we already have for Prac 2. So now let's see. I'm going to create a class called IIoT scanner. The IIoT scanner still has that scan method, but now we need to make it what? A pure virtual function. So by pure virtual function, we're basically saying that we need to make it abstract. So how do I make it pure virtual? I say is equals to 0 there, and then I say virtual here. So now this is an abstract method. Abstract in the sense that it's incomplete, it has no implementation. So now, since it's abstract, I don't have to define it here. I don't have to implement it. I don't have to do this here. Because what am I saying? By abstract method, it means that this is what it returns, nothing. It has no implementation because I wouldn't have a basic implementation. So for example, there's no general implementation. That's why I'm doing it like that. So for example, let's say we have the shape class, the shape abstract class. And this had, let's say for example, okay, let's make it public. The protected raw method, right? Raw shape, which draws the shape, right? And then I had two child classes or two children. I'm going to have a circle, and I'm going to have a rectangle. Since they will inherit all of this, I don't have to redefine them. They're just going to inherit. And then I specify who's this class's parent. This class's parent is the shape class. And then I do the same thing here. I do the same thing here. There's the draw method, right? So the reason why I have to make it pure virtual, because for example, here in the base class, if I was supposed to draw a shape, just some random shape, some normal base, some general shape, there isn't a general shape. Shapes are unique in their own way. So that's why I end up having to make it. Remember that I would have to make it, for example, virtual. Virtual, it means that you're basically telling the subclasses that this is overridable. Overridable means that they can override this function. They can provide their own implementation. But if you just write it as virtual, it's just virtual. That means they can decide, they have the choice of not implementing it because one class can take this base class's implementation, some other class can override it. But in this example, I have to make it a pure virtual function. Pure meaning that I don't provide any default implementations. All of these subclasses need to define their own version because there's no general shape. There's no generic shape. There's no shape that I can be like, okay, this applies to all. I can have a basic shape. There's no basic shape with general shape. So since there's none, I just make it a pure virtual function, meaning that I won't provide an implementation for it. The children will be the ones that provide the implementation. So we've made it pure virtual, and then this includes a private property of scan method, so of scan level, which is an enum. So I need to create an enum called scan level inside IoT scan. Let me do that inside IoT scanner enum scan level. It has two values, high and low. So I just put high and low. High and low values, right? And then it must still have, or that member function must take an IoT. Oh, okay, we're not done. So the private property method, that means I need to have a private member variable, a private property. So I need to go inside of my class after creating this function and say private, and then create a private member variable called scan underscore scan level. of type scan level. And if you check here, that's what they want. It should be underscore scan level of type scan level. What is the scan level? It's an enum. We did make the enum with two values, high and low. So we did do that. So the member function must take in an IoT reference as a parameter. We did take that. There it is still the same. So now I'm done creating this class. And since, like I said, this is a pure virtual function, I don't have to implement it here. I don't have to write that implementation. So we have the child classes, right? Okay, so since I don't have to implement it, I'm just going to copy this implementation because you're going to see that we're just going to redefine that implementation, but differently. So I'm going to have two classes, this IoT simple scanner and the IIoT advanced class. Those are going to be my two children. So I'm going to do this, create a file, header file, then .h. Then I remove the underscore included. And then I select all. And then I'm going to create the class IoT simple scanner. And then I'm going to create its source file or implementation file. .cpp, then add, and then all, finish. And then I'm just going to say hash include here, IoT scanner.h. And then now I'm going to create the IIoT advanced scanner class. And as you can see, they say that they both should inherit from IIoT scanner. They are both types of IIoT scanner, or both children of IIoT scanner. So .header file.h, I create the header file that contains its logical properties. And then I'm going to have class this, and then I'm going to have the second file, which is the source file or implementation file, .cpp, then add it to this, and then finish. And then I'm going to have a hash include advanced scanner, and then done. I have my child classes, right? So they both need to inherit from the IoT scanner. So I'm going to say public IoT scanner like this to say that these are children of the IoT scanner class. But then they don't know about IoT scanner, right? So I would have to specify the header file. If you check here, class name. So remember, when you're inheriting and inheriting from a class. So I need to do two things. I need to specify where where's the implementation of IoT scanner. So I include the header file like this. It will still complain. I'm not done yet because remember that I need to, okay, I think it won't complain, but I also need to define whether this thing is a class or not so that it knows. So yeah, we'll fix that later. So I can just include the header file like this. Okay, so we can, I don't think it's necessary for you to specify that this is a class, but let's just put the before declaration so that in the near future, if it does forget that this is actually a class, then, okay, for now, okay, let's not include it for now. Let's just leave it. Let's see if it won't shout at us as we continue. So these two classes must redefine the scan function differently. So both of them need to define the scan function. So the simple scanner, it checks if any of the readings. So be careful here. It's any of the readings. And then this one, if all. So the only difference is that here you're going to be using the or. So it's still going to be the same as this the scanner class. The scanner class's implementation that we had before. This simple scanner is going to just take that implementation. And then this one is going to take that same implementation, but instead of using or, it uses and because it's saying all of them, not just any, but all of them. So let's go back to our scanner class's implementation and copy this. I'm going to cut it and then start with simple scanner. Then simple scanner, I remove this and then I put it here. But then remember that we need to redefine this scan method in all of the classes because remember what he said. You said it's a pure virtual function. So that means all of my children are forced to implement this function. So I'm going to do this, but then I won't make it a pure virtual function anymore because I'm going to implement it inside of this class. So I remove the equals to 0 because the equals to 0 is what makes it a pure virtual function. I don't want it to be a pure virtual function anymore. I just want it to be a virtual function or a function that that we've inherited from the class and we are forced to implement it. So the simple scanner class, remember what I said about the simple scanner. It takes in the exact same function. It doesn't change anything. It implements it the exact same way. So it's just going to implement it the exact same way with no changes. And then it's just going to implement the exact same function with no changes. It's going to have or because it says if any of them. And then the advanced scanner, it's going to implement things a bit differently. So instead of using or, it's going to check if all of them are like that. So I'm just going to do this and then rename this to IIoT Advanced. So now instead of using or, this class will use and because it's going to check if all of them are equal to 0. And there we go. So that's it. You're done redefining the scan method. That's the only difference. You don't have to overthink it or anything like that. Just be sure that you read the instructions clearly because here it says if any. And that's the same thing we had with the IIoT scanner. So I just copy and paste it. And then with the advanced, it says if all. So that means I need to check all of them. So that means I need to use the AND operator. So inside, so that means we need to remember that it also says here we need to the constructor sets the underscore level to high for the advanced and then to low for the simple. So we need to have a constructor. So what I can do is for both of the children classes, remember it says both of them they need to have. So what I can do is I can go to my parent and create a constructor that sets this private member variable, right? So IoT scanner takes in a scan level like this. It takes in a scan level and then sets that scan level that we're getting and sets it to this private property. So I'm going to go into here and do this because I'm going to implement it now. And then I'm going to use a scope resolution operator to bind that implementation with the specific class it belongs to. So all I have to do here is I need to pass in a scan level. So I'm just setting the private property of which I called it underscore scan level is going to be equals to that scan level that I'm getting from the user. That's all you have to do here. Because why am I doing this? Because I'm going to you remember constructor chaining, right? So you can use constructor chaining if there's inheritance involved. So the derived classes, they can chain their constructors implementation to the base classes constructors implementation. That's why I'm making it simple and just creating the constructor in the base class. And then for my child classes, instead of me creating that constructor that takes in a value, I just create a default constructor, a no args constructor. And then I'm going to create same constructor here. Yeah, I'm just going to create a no args because I don't want it to force me to have to create, to have to pass in a parameter. I don't want it to do that. I mean, you could, it's still fine. It's not like there's anything wrong with it, but I just don't want having to work that hard. And then I go into my simple scanner. I also write the implementation file, the implementation of this constructor like this. Then now the only thing that I have to do is chain this constructor to my base class's constructor. How do I do that? The same way we've been doing it. I'm just going to do this and say chain to what? IIoT scanner, my base class. And as you can see, it takes in a what? A scan level. So what scan level am I going to pass here? I think for the simple is low. So yeah, for the simple, I should set the scan level to low. So I'm going to set that to low. So I'm just going to say low here. There we go, done. And then for the advanced, I'm going to set it to high. So I'm going to come here and set this to high instead of low. It knows about all of this because I did include the IIoT scanner header file. So it also knows it also knows that I have an enum defined inside the IIoT scanner header file. So we are done doing everything here. We're done with everything. So it still has an IoT scanner object that it manages its life cycle, but then there's things that need to change. So it has a scan method. So this scan method is going to delegate the task to the correct class, either the IIoT advanced scanner or IIoT simple scan. And then the toString is still the exact same way. We don't change anything. So the important part here that I want us to look at is this part about the construct. That's where everything is going to change everything automatically. Like for example, the scan method, it will know which scanner to use. So now what I'm going to do is I'm going to add this additional property. So that means our constructor needs to take in an additional property, which is a Boolean. And then it's going to be when it's true, when you pass true value for that Boolean, it means that we're creating an advanced scanner. When you pass in a false value, that means you're creating a simple scanner. So let me go back to my IoT monitor class in the constructor. And then I take in an extra value, which is a Boolean. And then I'm going to also have a constant static const bool default scanner where I'm going to define a default scanner. It can be any scanner. So let's say by default we use the advanced. We use the advanced. I need to also have that, but I don't know. It's not necessary for you to do this, but let me just do that. And then now in my constructor, I need to update it and say bool BLM scanner. So takes in the type of scanner. And then remember that when we're chaining the default constructor to this constructor, we need to also update because now it takes in an extra Boolean value. So I'm going to say default scan. So by default, it's going to use true, which means it's going to create an advanced scanner by default. All right, and then done. So the tricky part is here. This is where we need to change. So how will that change? Here it's going to change because here they said if that Boolean value that we're taking in, if it's true, I need to instantiate or create an advanced scanner. So how do I check if it's true? You just say if BLN scanner like this. If I say if BLN scanner, it means that I'm saying if this has a truth value of true, or basically it means that if this is equals to true, then do what? Do something, right? And then I'm also going to have an else here, or when it's false. So when it's true, this is when it's true. Because remember the if statement conditional part, it only checks if the condition is true. If it is true, then do something. So let's do the thing that we want to do. So I need to create or instantiate an advanced scanner. OT advanced scanner, right? So that's what I need to instantiate. Else, I need to instantiate a simple scanner. So new simple scanner like this. And we're still managing the life cycle. So there's nothing changed, but then now we're just managing two different types of scanners because now this scanner class has become advanced. So he doesn't know about IIoT advanced scanner. Type specifier. So at this point, it's going to give you a random error because it doesn't know what to do. So what's going on here is that it doesn't know about IIoT scanner. So what I'm going to do is I'm going to hash include the IoT advanced scanner class and then hash include IoT simple scanner class, the header file, so that it's aware of what's going on. So now I need to go back. Before we continue, let me do the forward declaration. So class IoT advanced scanner, that's the forward declaration for it. And then class IoT simple scanner, like this forward declaration. And then build. And then I also need to, it's complaining about incomplete type. So it's saying it's incomplete. What is in essence what is really an IoT scanner, right? So what I'm going to do is I'm going to do another forward declaration here to say that this is a class. Don't worry about it. I know what I'm doing. This is actually a class, but you will get the implementation later. For now, you won't get the implementation. Let me see. Why is it complaining? Incomplete type. Oh, this is a different class now. Oh, but no, it's still the same error. But let's see, IoT scanner. That's the class. Then build. And then let me see. Oh, okay. So even the IIoT scanner, we also need to include for some weird reason, it's saying it doesn't know about IIoT monitor. So I also need to include IIoT monitor inside. So hash include IIoT monitor.h. I think let's fix that first. And then let me fix this here too. I'm just going to add it at the top. The hash include IoT monitor.h so that it knows that IoT monitor is actually something that that exist. So now it's complaining about this constructor, the chaining of this constructor. Remember that we're now taking in an extra Boolean value. So I need to say comma and then use the default scan for scanning. So I just need to add that there and then build. And then, yeah, I think those are all the errors. Has not been declared. It also wants for a declaration. Okay, so let's do that. So it's like what doesn't really know that IoT monitor is a class. It's not aware, even though I mean I did okay, and I did include it inside the scanner header file, but it's still basically saying that's not enough. You need to redefine it again so that I know that this is actually a class before we can continue. So now we're only getting two errors. So now what could be the cause of this? Because incomplete type IoT scanner. So incomplete type. So let's do this. I think the main reason it could be complaining is because it didn't see an implementation inside of this class. Remember the scan method that I said we shouldn't implement. I think that's why it's complaining. So let me do this. But then I won't provide any implementation. So I'm just going to leave it like this. To do. I'm just going to call it to do, put a comment to do here. Derived classes will implement this function. And then I put back, okay, I'm going to put it at the top. I put back the implementation of that construct. I think this could be the reason. Okay, that's still not the reason. Okay, that's still not the reason. So I should just remove that. That's not the reason for this issue. Okay, so incomplete. Why is it saying, why is it complaining about incomplete type? Invalid use of incomplete type. Thing object which has a non-virtual destructor. Virtual destructor. Let me see. Deleting an object of an abstract class which has abstract, but it doesn't really matter because at the end of the day, when the object is created, it's complaining that this is an abstract class, you can't do that. But at the end of the day, when this object is created, the monitor object, when it's created, we also create the scanner class. And depending on the truth value of this, we're going to create the actual scanner, that the type of scan. If it's true, we're going to create an advanced. If it's false, we create a simple scanner. So let's see, incomplete type of IoT scanner. Let me see. IoT scanner. Why is it saying incomplete? Is it because of the virtual function, the pure virtual function? But it shouldn't complain because I redefined the virtual functions inside of this class, the scan method. I did redefine it, so it shouldn't be complaining. I don't think that's the issue though. So let's see. Let me remove that and see what it's going to say. Yeah, that's not the issue. Why is it saying it's an incomplete class? Is it because it doesn't see a distractor? Let me see. I think it's because it doesn't see a distractor. So IoT scanner like this. Copy, and then implement this. Maybe could be because of the distractor. So let's see now. Expected class name before token. This is a class name though. Oh, okay, I didn't declare it properly. It's IoT, not IIOT. Then let's build again. Still complaining about the type. Why is it saying it's an incomplete type? Let me see. But we do usually have a virtual destructor. Yeah, we do have a virtual destructor that each class is going to inherit. Come on. Why is it complaining? IIoT scanner. Let me see. It is the same class, though. This you shouldn't be complaining about incomplete. Let me do this. Let me remove it and edit again. Okay. Now it's complaining, saying that it's not a base class. It's not a direct base of. So basically, it's complaining that because I removed the inheritance, so let me build it again. What could be the issue for this? Incomplete. Is it because of this forward declaration? But without the forward declaration, okay, let's use it without the forward declaration. Let's see. Excuse me. So let's build again. It's still complaining. So let's build again. Okay, why is it still complaining though? Incomplete. Let me check something. Let me do this. Let's say I change this to protected, something like this. It will still complain. Okay, it's still going to complain. Why would it say it's incomplete? I mean, I did include everything, the forward declaration and all of that. Public IIoT scanner. It does have everything. So I did define the destructor. I just forgot about that. You have to define a virtual destructor. It means that it's going to be inherited. It's going to be inherited by all of the classes, right? So you can make it virtual so that they could all of them define it differently, or you can just leave it like this. So by default, they're going to inherit this destruct. So you can just leave it like that, or you can redefine it. You can use a virtual function. So let me see. What if I also create destructors for them? Could that be case? But I don't think that's the case. It's complaining about something else. The scanner class. I don't have to do this because it inherits by default. So IIoT scanner saying it's an incomplete, invalid use of incomplete type. IIoT scanner. Note forward declaration of. So some weird reason is taking this forward declaration as an incomplete class. Yeah, I think that's what's going on here. Let me build again. It's saying redefinition of the IoT scanner class. This thing is mad. One moment it's complaining that this is now it's saying that I'm redefining it. Okay, so let's remove the forward declaration and then see what happens. Build again. So now it's complaining about, okay, it's complaining about two errors. Wait, didn't I just remove it right now? Oh, it's only in there. I didn't remove it here. So build. Did you mean IoT sensor? Does this name a type? You see, so that's the problem when you don't have the forward declaration, it won't know, it won't know whether this is a type or not. So you need to do the forward declaration and tell it, okay, this is a class. It is a data type that I've defined. So let me see. Invalid use. Okay, it's complaining here. Yeah, it is still the same class. And then it's complaining in the header file for the simple scanner. This is IoT simple scanner. OT scanner. Why is it complaining though? Because everything is fine as far as I know. Oh, I think it's complaining about the invalid, the distractor. Yeah, I think it's complaining about the distract. So let's go here. Then let me scroll down. Here it's complaining about the distract. I don't know why it's complaining though, so let me do this. I think that could be the issue. Okay, that's not the issue. Let me do that build again. Invalid use of incomplete type. What could be the issue behind the invalid use of incomplete type? Because everything is done properly. Let me think. So we inherit from the IoT scanner. I include the header file, and then I do the forward declaration. And then, yeah, that's pretty much it. Mm, Let me think. What could be the issue here? Mm, Everything seems to be fine. I have header files and CPP files for all of them. And I have the destructor that I've defined, but I don't have to necessarily define because its life cycle is going to be managed by, yeah, I don't need to have this. It's going to be managed by the monitor class. So yeah, I don't necessarily need that destructor, but for now, that's not the issue. We need to fix this symbol scanner. Let me think. That's if I remove the header file, it won't work. That so with this error of the incomplete type, it's usually because of me not putting the hash include, right? So let me do this. Let me sort of like let me define it after and see if that makes a difference. Okay, I think that makes a difference. But here I had defined it before, right? And here in this class is defined after. Yeah, I don't know why it's complaining. Basically, it's complaining that it can't find the implementation, but I did include the header file though. It shouldn't be complaining. Then, yeah, this thing. Then I'm going to do this, put it there. Because this error is usually when you didn't do the imports properly. What if I do this? I just remove that. Um, okay, it's still going to complain that I didn't declare the monitor class. So I'm going to do that. This is the IoT scanner. I don't know why it's not finding it. Basically, it's complaining that it can't find the implementation of this class. It doesn't know what implementation it has. How should I do this? Like include the header files on their own, then the forward declarations on their own. Let's see. that actually does anything. Okay, and then let me put it after the monitor class. Let's do complaining. How can it complain about not finding the implementation when the implementation is there? I mean, I do have the implementation for this class. Invalid use of incomplete type IoT scanner. Or could it be because of the constructor? Could it be this constructor that's causing it? Let me go back there. But this has its own default constructor, even though it inherits that construct. So let me do something like this. Let me put in high and low. Because at this point, I'm just testing it out. I'm trying to see where it's actually having an issue. Yeah, so this is fine because these classes there's no constructor that I've made like this. So, but I'm just using the default constructor. Sorry about that. Um, Invalid use of incomplete type. Is it because, let me see. Is it still because of the destructor? But the destructor should be fine. IoT monitor, this should be fine. Uh, I don't know, for some reason, I'm seeing this comment saying the destructor. It's like it's complaining about the destructor or something. And then now it disappears. It's like, okay. Yeah, that's the problem about this thing. It gets confused even though you did write everything. Because now it's like it can't find the implementation. How can you not find the implementation of IoT scan? How can you not find it? When I clearly have the implementation, the header file and the source file. So IoT scanner build IoT scanner build. Then IoT scanner. At this point in time, I'm not sure what the error is because now it's only complaining inside of this class. So let me go to my IoT scanner. So I do have this forward declaration and that. Then I have this class. There's the implementation of the class. IoT scanner. The simple scanner is no longer complaining. I don't know why it stopped complaining. Let's do this. It expects a class name, right? So let's just do it from scratch, right? So I'm just going to include again, hash include IIoT scanner like this. And then okay, Okay, still complaining. It's like, okay, you're supposed to, this is supposed to be a class T scanner, then build again. Now it's complaining about the IIoT monitor, right? So what I'm going to do is I'm going to hash include IIoT monitor.h. Okay, still complaining that IIoT monitor has not been declared. So I'm going to say class IIoT monitor. Okay, they have the exact same spelling. So now I should stop complaining. Okay, it's still complaining. Let's see. Invalid use. Why would it say invalid use? Because we've used it properly. If false, create an advanced scanner, a simple scanner. There it is. If it's false, create simple scanner. We did all of that. Or maybe it doesn't like the fact that I'm chaining it, something like that. Let me do this. Let's see if, but the chaining shouldn't be an issue. Yeah, the chaining shouldn't be an issue. Why would it complain about the incomplete type? Mm. Let's see. This is not an incomplete type though. Okay, let me remove this distractor. It's not necessary because I am going to. Why could it be complaining about this? Because I did do the imports and everything properly. Because right now it's complaining about the imports. Or maybe it wants me to do it like this. Let me do that. Okay, that's not the issue. Because sometimes it can be small things. Incomplete type. What could be the issue? Because even if I try and change this, everything is fine though. Like literally everything is fine. Let's try and change this to protected. Yeah, everything is fine. That's not even the issue. Everything is fine. I don't know whether code block is one that's just complaining or what, because everything is fine. Like literally everything is fine. There's nothing wrong here. There's nothing wrong. Nothing wrong here. I don't know why it's complaining. I mean, everything is everything is included in the IoT scanner. So hypothetically speaking, if I just do this, that should work. But I know it's not gonna work because this thing has a mind of its own. Yeah, let me do this. Yeah, as you can see, this thing has a mind of its own. Incomplete type. Okay, let me do something like this. Let me leave it like this. Right. But wait, I just have to include the header file. That's all I have to do. Let me do this. Let me include the header files only and leave it like this. And then in my scanner class, let me do this. Let me say scan level like this. And then I'm going to say here obj monitor like this, right? And then let's see what happens. Has not been declared. Yeah, at this point, code blocks is just complaining for no reason. So class IIoT scanner, there's the forward declaration. So it does name a type. Just stop complaining. Then class IIoT scanner, there's the forward declaration. Just stop complaining. Invalid use of incomplete type. How though? How can it be invalid use of incomplete type when it's complete? There's nothing missing. There's literally nothing missing. I don't know why code blocks is doing this. Let me see. That should be incomplete type. Yeah, I think if I just use the header file, everything should be fine. Then, yeah, let me see.